Now, I will tell you the producing process of solar glass. This is the solar glass we are testing.
Carried out by depositing a
And this thin film is the silicon here. This is the coating of the semiconductor here. Semiconductor. So you can look the black color here is thin film silicon. It's a kind of semiconductor.
thin film of silicon onto a glass substrate which can yield high efficiency and lower cost. Moreover, there are plenty of raw materials.
This is a kind of coating technology, and we coating the semiconductor on the glass. And there are many layers coating on the glass.
This technique can be divided into 3 processes: preparation of transparent conductive oxide coating glass, cell fabrication, module assembly.
Okay. The first technology is this partition. The partition here. This is the glass, but the glass is not a conductivity. So we need to let the glass become a conductivity. So we need to coat in a material we call TCO material. The TCO material we call it a transparent conductivity oxide. Transparent conductivity oxide. And we coating on the back to let it can transport the solar power. And the second layer, the black color here, is we call the coating of semiconductor. And then we laminate 2 glass together. We call it a module assembly technology.
The first process is TCO glass preparation.
And now we are introduce the first layer, the producing of how to produce a glass, and the glass can become a conductivity of electricity. So if you have interest in for the solar energy, please listen carefully about this video.
This process consists of 6 steps. First, trim TCO glass to reduce its sharp edges by using glass edge trimming machines. This TCO glass acts as the positive electrode of solar cells. Second, wash trim TCO.
For the solar glass, the clean is very important. So we need to clean at each step to assure the glass is very clean during the producing process.
Glass with deionized water to remove existing contaminants after the trimming process and then drying it. Third, cut thin oxide film coated on TCO glass into small cells by using a laser.
It's a laser cutting material, laser scriber machine. You can look there are many lines here. It's by laser
subscriber.
This is for laser subscriber. Yeah, this is because this is the coating of the TCO material. The coating of TCO material. So we need to do scrap scrap or cutting here. Yeah, so you can look the cutting here. And the TCO is a transparent conductivity. And we say when you become a conductivity, you need to some metal to become the conductivity.
Fourth, wash TCO glass again to remove.
And when we finish the coating of TCO and also finish the cutting of the TCO, and we will go to washing again.
Remove existing tin oxide dust after the laser scribing process and electrical charges have been removed from the surface of the TCO glass. Fifth, put several TCO glass.
And in the factory, you need to use the carrier, back carrier, because you need to guarantee the glass is no crack, because the glass is brittle material. So when you do the processing of producing, it's important to carry carefully to prevent the crack on the glass.
Glasses into a box carrier which is developed by SolarTech. With this box carrier, thin film silicon is coated onto every TCO glass uniformly and consistently. Finally, heat box carrier containing TCO glasses up to 200 degrees Celsius in a preheated chamber in order to prepare.
When we finish the partition, we need to do the preheating 100 degrees C to preheating, because the next step we will coating the material. This material is a semiconductor. So before coating semiconductor, we need to do the preheating of the glass.
Compare the temperature of TCO glasses for the next step, which is plasma enhanced chemical vapor deposition, PECVD. The second process is cell fabrication.
So now we start to coating the material here. Is a semiconductor
process. This process consists of 6 steps. First, the most important step in
this is a coating. The coating is inside a vacuum environment.
Manufacturing solar cells is fabricating 6 layers of amorphous silicon onto prepared.
And the process of the coating we call plasma enhanced chemical vapor deposition. This is inside a vacuum environment.
TCO glass by using plasma enhanced chemical vapor deposition. Second, reduce the temperature of TCO glasses by using cool-down machine in order to save cool-down time.
After we coating the semiconductor, we need to do cool-down.
Third, cut thin silicon film, coat on TCO glass into small cells by using a laser scriber.
We do the laser scribe again, because the red color here is a semiconductor. So we need to cut in the semiconductor again. So it's the second time of cutting, second time cutting for use laser scriber. So this is the second time scribe cutting for this one, and this one. So it's the second layer cutting to cutting on the semiconductor. You see, it's a silicon. The material is a silicon. This is a kind of, this is a kind of semiconductor.
Fourth, coat with zinc oxide and silver by using physical vapor deposition machine. These zinc and silver layers act as the negative electrode of solar cells and enhance light reflection back to the solar.
And this is the last layer. The last layer is also a conductivity. We use this kind of metal to become the conductivity for the third layer.
Cell.
That's why you can look some dark color, because this is the color due to this is a back contact. Back contact is you see is a silver coating. The silver coating on the back for the conductivity. Silver. So you will look this conductivity, semiconductor conductivity. As I told you before, this is a generate solar power and the transport electricity. Generate electricity here and the transport on the top, transport on the back to transport the electricity. So this is a back metal.
Fifth, the cutting of the surface of the glass substrate again. This time, all layers of thin silicon film, zinc oxide, and silver will be cut.
And this the third time. There's a cutting here. There's a cutting here. For there's a cutting, and I will tell you why.
Out.
So you will say, you will look. Actually, you see, generate power, and the electron come here, and there is a conductivity here, and go back to, you see, go back to here, and the conductivity, and the generate solar power, and the conductivity, and go here, and go to left hand side and the right hand side.
Finally, test the performance of the solar cells by using a sun simulator. The last process is module assembly. The module assembly process.
So now we need to use the second, the back glass attached on the back. We call this assembly.
This process consists of 7 steps. First, remove the film at 4 edges of the solar cell by using a sandblasting machine to prevent short circuits and also to make the surface suitable for lamination. Second, bond conductive aluminum tape onto the solar cell by using an ultrasonic bonding machine.
This is the process to attach the wire here. You see, it's a silver wire. shearable wire here. Shearable wire here. So the solar power generate the minus the electron come here, and then come here, and to the meter, and then come back here, and then come here, and come here. So it's a circle like this. Because the solar power generate come here, and the conductivity come here, and then come here, go outside for the bubble, and come back here, and then come here, the conductivity come here, and then come inside. So it's a circle. So this is the install of the wire, install of the wire on the left hand side and the right hand side.
Third, lay down a Teflon sheet on a tray, then placing the solar cell on it, and then after that, lay down an EVA film on the solar cell.
This material is for combine the two glass together. This is we call EVA material.
Drilling a hole through the EVA film and then placing aluminum tape through this hole. Then, placing the other glass on top. Finally, covering the tray with textures and a
Yeah, this is, you can see the shearable wire.
Viton sheet.
This is the final glass. This is the back glass to laminate on it, laminate. Yeah, so this is the producing process of our solar glass.